Hello, my name is Munoz, and I'm going to be presenting about heat and temperature. We're going to start off talking about heat. So, heat is the buildup of energy, and that creates an increase in temperature, which we feel as a sensation as being hot, or we can also see it as a physical manifestation as bubbles while the water is boiling. We can see things turn red. What really is happening there, though, is that atoms and molecules are distancing themselves from each other, and that's creating energy, which leads us to thermal energy. So, thermal energy is the energy that is created within a substance or within molecules, atoms, elements that are separating, moving. So, the containment of this energy causes a rise in temperature. It's important to know that thermal energy is also kinetic energy. So, while it's being contained in one space, the molecules and atoms are also moving inside of that space, and that's creating what we perceive as heat. Another thing that's important to note about kinetic energy is that you could feel this heat when you're tugging on a rope, for example, or when you get a rug burn. We feel that heat. So then that leads us to temperature. So temperature is a measurement of the release of energy. So it's common knowledge that heat increases the temperature scale. And in regards to temperature, we measure that by using a thermometer in either Celsius, Fahrenheit, and sometimes Kelvin, which is not very common. And Celsius is not very common in the United States either, but that is a measurement. So Celsius was developed by Andre Celsius. It's the most commonly used scale in the world. Celsius is a unit of measurement used to determine temperature. The scale of Celsius. So 0 degrees Celsius is a freezing point, and 100 degrees Celsius is a boiling point. If you notice, a lot of the examples use water because that is something that's readily available to labs all over the world. So as a way to have like a controlled substance, they use water so that everyone could be on the same scale and the same understanding. Then we go to Kelvin. So Kelvin is named after the physicist Lord Kelvin. We don't really hear about it, or I didn't really hear about it because it's mostly used by scientists and in labs. The reason for that is that this scale is an absolute. So it actually measures temperature by determining the kinetic energy in atom and molecules. So that makes it absolute and very specific and very precise. The scale for Kelvin is the they don't refer to it as a freezing point. They refer to it as an infinite cold, and it starts at 0, and that's equal to negative 459.67 degrees Fahrenheit. So now we're going to Fahrenheit. So Fahrenheit was developed by Daniel Gabriel Fahrenheit. Only 7 countries continue to use this measurement, which includes the United States. It was most commonly used in English-speaking countries. It's used to measure temperature, and since it's most commonly used in the United States, that's the one that most of us know. And actually, on a trip to Mexico, I was very confused when I asked my cousins what temperature it was, and they gave me the temperature in Celsius. I was thrown off my game. So that's really interesting. I think maybe we should start using Celsius since most of the world uses it. It would be less confusing when we travel. So the scale for Fahrenheit is 32 degrees, which is the freezing point of water, and the boiling point in Fahrenheit is 212 degrees. Um, yeah. Okay, so that is all I have to say about heat and temperature. And thank you for your time.